There are a couple of videos that I have in this worksheet that I want you to watch before you get started on this. I want to make sure that you watch this video. It's in your Canvas link. And there's also, down here, there's this video. They're great explanations of what a log is and where we come up with the number for E. So if you can watch those, that'll make this video now make a little more sense. So one of the things we want to talk about is why log base 10. So I'm talking about this part right here. So why log base 10? And we did log base 10 basically because we've got 10 fingers. We use 10 for our number system. We're a 10-base system. And if you notice that, we have everything in multiples of 10, so we've got like a multiple of 10 and then 10 more, right? So 10 times 10 is 100, and 100 times 10 is 1,000, and that gives us our place system. And then if we divide by 10, we get a tenth. And if we divide by 10 again, we get a hundredth. And if we divide by 10 again, we get 1,000. So it's, the base system is what we use in our decimal system, so it sort of makes sense to have this be a common base that we talk about in mathematics. I'm going to use log base 10 to describe a little bit what we're talking about. I'm going to start with an exponential of 10. So when I'm looking at this equation here, I have an exponent with a base of 10, and so I want multiples of 10. And then I made a table here where I put in different values here for my x. And when I put in different values for my x, it changes my output. And I put a -3 in here, and it puts that 10 in the denominator, and then I multiply the 10 times 10 times 10, which gives me 1,000, right? And then the same thing with the -2, puts it in the denominator, and I get the 100, and so on and so forth as we move down this table. The thing that I want you to notice is that there is a relationship, and I'll write this one in, there's a relationship between these components right here. So if I'm looking at this guy, and I'm comparing it to this guy and that guy, what I have is something with an exponent of a base 10, and then over here, I have a log with a base 10. And they have a relationship. And what I notice is that the x and y values have switched places. And that's going to be true all the way down this column. So these two switch places here, and these two switch places here, and so on and so forth. So all the way down, where my 3 and 1,000 and my 1,003, they just switch places. And what that does is it changes how the graph grows exponentially. When I have this exponential function right here, it's going to grow exponentially along the y-axis. And when I have this log base 10, right, it's sort of this exponential that grows along the x-axis. So they still work exponentially, they just grow in different directions. So when I graph these, this blue line right here, this is growing exponentially along the y-axis, so it's going to get taller and taller and taller. And then this green one is growing exponentially along the x-axis, and it's going to get closer and closer and closer to the x-axis as it grows. One of the things that happens when I'm talking about exponents and logs have the same base is that they are symmetrical, which means they look the same on both sides about the line y equals x. So I'm going to write this in here. So this is my y equals x. This is going to be my y equals 10 to the x, and this is going to be my y equals log base 10 of x. So when I graph these, this is what I get. So if I fold it along this line right here, these should be lining up. Okay. So Again, make sure you watch this video on E, and E explains things in nature, and that video will do a really good job to explain that for you. And it's a very common thing we use, and it's often used in economics. And so we use a base of E to explain things, as well as using a base of 10 to explain things. So in our calculators, we often have these two different bases, a log key for our base 10 and a log key for our base E. And on our calculator, we have a log, and we don't write down the base 10. We assume that this base 10 is there, and they just never write that part down. It's just an assumption that we all know what we're talking about. And then the other one is the ln key, the natural log key, and we write ln for short for that. And those are the two buttons that we have on our calculator, and they are really helpful in simplifying logs that aren't our base 10 or our log base E, which is this guy right there. That's the shorthand for our log base E. And what I can do is do what we call a change of base. So I'm going to write this in, say this is a change of base. And the way the change of base works is that I'm going to make this a little smaller. I'm going to make a log here with this top part, a log of 8, and that comes across here, a log of 8. And then I'm going to divide by this bottom part right here, this log of 3, which gives me a log of 3 in the denominator. And I can get my output. So my log of 8, I'm using this log base 10, which really doesn't have this 10 written down, so I'm going to erase that. This on your calculator, so I put in log and then 8, and it spits out this decimal. So my calculator will do this for me. And when I do my log 3, I just push the log button and 3, and it spits out this number in my calculator. And then when I take this fraction, I divide the top and then by the bottom, I get this output here. So it's a way to get around the fact that I don't have a button for my log base 3. I'm going to do this next one. I'm going to do my log of 6 in the denominator, and then I'm going to do my log of 24 in the numerator. I'm going to grab my calculator and say, okay, if I have a log of 24 in the numerator and then log of 6 in the denominator, and I have to do this in my calculator quick like. I say log of 24, and this gives me 1.38-ish in the numerator. And then I do my log of 6, and this gives me 0.778-ish in my denominator. I'm sort of rounding here. And then I'm going to do the division and take 1.38 and divide that by 0.778. And that gives me 1.7737, which is about 1.774. Okay. And that's how I can get around that base of 6.